Hi all. Today we will be seeing the introduction of Drools, and I'll be walking you through most features of Drools and the architecture, how it is modified, and what are the advantages and disadvantages of using Drools, and we will see in depth. So this is the high-level architecture of Drools. If you see, Drools is a community project, and the enterprise product's name is BRMS, JBoss BRMS. So they have packaged into the enterprise product as having a support warranty as well. So it's named differently, but both are same. BRMS is built from Drools. So what is Drools? Drools is a powerful decision management system. It's a decision management system basically, and it has got some complex event processing features as well. We'll go to the complex event processing features later on, but first we will look at the decision management system. So in our applications in today's world, we have a lot of complex applications that are being developed and a lot of stuff that we are automating, which is so complex in nature. And all that business logic resides in the actual application that we develop. And these applications are mostly developed on the object-oriented programming concepts. But since the business logic is residing inside the application where there is still algorithm also written, it is very difficult to maintain the business logic. So Drools provides us a way to externalize and localize the rules and then manage it in a separate system and then plug it into the actual application which needs those business logic to be processed. It also provides us a rule engine which will be able to execute those rules and take some decisions based on it. So it's basically to externalize, localize the rules, run it on a separate engine which is more efficient in executing the rules and provide the results back to the application wherever it is used. There are also advantages and disadvantages to it. We will see in the coming slides. So on a high level, we will be seeing this is the architecture that is the current rule engine that is following. So if you see, this is a minimized version. There are lots of other components also involved, but I have just since it's let's assume that it is from a 30,000 point of view how we are seeing a rules engine. So there is this knowledge repository. When I say knowledge repository, it contains all the artifacts that is necessary to be given to the rules engine. So we would be writing business rules in the form of .drl files, and we would be also having the rules can reside in two formats. One is the .drl files and the other is the decision tables. Decision tables are nothing but the Excel sheets. You would write a lot of rules into the normal Excel sheet and then upload it to the engine. An engine will be able to pass those rules and then take appropriate actions on it. And you have Java model, and this Java model is the actual data type or the custom type of the data that is going to be manipulated by these rules. So the first two are the actual rules part, and the third is the data part. So this is the data that is going to, this is the type of the data that is going to flow through these rules, and that is going to be manipulated, and these rules are going to be applied on those data. So we need to know if a data comes to interpret what data is coming, we need to know the type of the data. So that's where this Java model comes, and basically this whole rules is developed on Java, and it's a full and full Java system. And so here we have this rules engine, BRMS. So this is the one which is going to execute all these rules on the data part. So it will get all its artifacts from the knowledge repository, and then it has got a storage as well. It does persist some of the execution details and other details that are required by systems to invoke it and all that. So basically this knowledge repository, if you see in the low level, what this means is it's a Maven repository. So all the artifacts that we create will at last be residing into a Maven repository. How does it happen? So what does a Maven repository basically contain? It contains a lot of jar files. So whatever artifacts that we create, it will at last be packaged into jar files, and then it will be packaged into jar files, and those jar files will be deployed into the Maven repository, and the rule engine will be able to derive those artifacts and the type and during runtime from the Maven repository and make use of it. So this is the high level overview of Drools. We'll move on. And this is how a rule engine works. This is the working of a rule engine. In the previous slide we saw how it is at high level, how does the components fit, and this is how a rule engine is going to work. So in the center you have the rules engine, that's fine. So we have two items here, one is the Pojo and the other is the knowledge jar. It's the same thing which I showed there. This is the Pojo, the fact model. So here facts are nothing but the data that is going to flow through the system, and the data that is going to be processed, the rules are going to be applied on that data. So here the data is being called as fact. The instance of data is being called as fact. So this is the type of this Pojo. This Pojo is the type of the fact. So we would be creating Java models, fact models, and then we would be placing them in the rules engine. We will be deploying them as part of the rules engine. So when a data comes in, the rule engine will be able to use one of the will be able to interpret the data that is coming in by applying it to using one of the fact model that we created and kept already. And this knowledge are, these are the actual technical rules and the DRL files and the decision tables that we create. And this is the actual rules part which the rules engine is going to work on the data. So these are the two input for the rules engine. It will be developed and packaged and then compiled and deployed, and at runtime these are going to be used. And both of these stuff are going to reside in Maven repository. That's our knowledge repository. So knowledge repository and Maven repository are interchangeable. So facts. So facts are the data that is to be processed. So when a rule engine is in execution mode, when we want the rule engine to process something on some rules of the data, we need to give it some data. So that data is a fact. That is the incoming data into the rule engine. Actions or outcomes are the actual consequence part of applying the rules on the facts. So if you see, the fact model tells the rules engines how to interpret the facts. Facts are the actual data that is to be processed, that's the incoming one. And the rule engine applies this technical rules or the DRL rules on the fact, and then the rule engine takes the specified actions based on the rules set fire. So it's going to take this is the consequence part of applying the rules on the fact. The rules tell the rule engine what actions to take when certain conditions are met. So the rules are the ones which is important, which tells what actions need to be taken on the fact. And we will see the basic structure of a rule now. And before going to that, what exactly is a rule engine? See, rule engine concepts, the history and all, if you see, it comes from artificial intelligence background, and there is a lot of work that has been done. It is derived from the production systems and all that. Basically what it does is it provides this KRF functionality. What is KRF functionality? Knowledge, representation and reasoning. So we are representing the knowledge in the form of rules, DRLs and the decision tables. That is the knowledge representation. And the reasoning is we let the system reason on the by applying the rules on the data that comes in and reason out what action that needs to be taken out. We actually only declare the rules and give it to the system and then pass it on the data to be acted upon. But we never tell how to apply these rules and what actions need to be taken. So like what actions need to be taken we do tell, but we do not tell it how to execute these rules and what way. So all that is done by the engine itself. So it's more of an artificial intelligence. The system does learn and it does a lot of a human cannot do all that processing by himself, those complex process, by just having those set of rules. We will, if we have to code it, we have to tell the system how to do it. The algorithm that is used behind the scenes, the freak algorithm that is used, is the intelligent algorithm that makes all this rule engines functionality come to life. So it provides us this knowledge representation and reasoning functionality. If you want to know more about it, you got to dig deep into the artificial intelligence stuff and how that is working. And that's the rule engine. It at last executes, applies rules on the facts that come in and takes up actions accordingly. How does the rule actually look? It's a two-part structure. A rule, and you have the when condition and you have the then condition. So then actions part. So when is the conditions part? So when is the keyword, and you can write some constraints in the left hand side of the equation. So For example, here you have given username equal to Fedra. This is the condition that needs to be satisfied for the then part, for whatever you have written on the right hand side to be executed. That becomes your actions part. So when and then. So this is the basic structure of a rule, nothing more, nothing less. And this name, this quotations is not required if you have name without space. And if you have a space, then yes, quotations are required. Otherwise, this is the basic condition, when part and then part. So what it says is, when all the conditions on the left hand side, you can have more than one conditions on the left hand side, and if all the conditions are met on the left hand side, then the right hand side part will execute. So that's what it means. When all the conditions are met, a rule will fire, actions will execute. This rule will be fired if these conditions are met. Now let's look at a sample rule, how it looks. This is a sample rule, rule hello Fedra. This is the rule name. Since it has a space, I have even put it within quotations. When. So this is the when part. User name equal to Fedra. So this is a constraint part. This is the condition part which needs to be satisfied for this rule to fire. What it says is user. User is an object. It's a model, Java model that needs to be. So the data that comes in for this rule, if it is of type user, so this is the first constraint check. This is the object constraint check. So if the data that comes in is of type user object, then go and check the constraint part, the field constraint part, name equal to Fedra, name equal to Fedra. So user object is having a attribute name, and that should be equal to Fedra. If it is equal, then this condition has been satisfied and the rule is going to fire. When I say rule is going to be fired, that means then part of the rule is going to execute. So here we are just executing system.println hello Fedra. There are two syntaxes that we can use. One is of Java, one is of MVL script stuff. So herein I have used the simple Java statement, sysout statement, where I am printing hello Fedra. So this is a very basic example of how a rule looks like. Again, onto the constraint part, this is the object type. It is going to match the data that is coming inside the system. So the data that comes in the system should be of the type user to match it. And then it is going to have a name attribute, and that name attribute's value should be a Fedra. So this is a field constraint, name equal to Fedra, and it uses a literal constraint here in the form of Fedra. It's a literal. You have directly given a string input here. So that's a literal. So if it satisfies, then it's going to go ahead and execute the then part of the rule. And the pattern, this is the one which makes everything work, pattern matching. So we'll see how a pattern looks like. Whatever we saw here, this is the pattern. The username equal to Fedra, that is the pattern. So here we have given a different thing, a rule, some other rule here, CL:claims. So this claims part, this is the pattern actually. And this claim amount greater than or equal to 1000, this is the pattern. Whatever is after the colon, those are all patterns. Now, in this pattern, we have not given any field constraint. We have only given an object constraint. That is, the object that is coming in should be of the type claims. Only that we have specified. And we will, like this condition will satisfy for any claims object, regardless of what data it is going to contain within it. Like the claim amount can be 10,000, 20,000, whatever it is. When an object of claims type is going to come in, this condition, the first condition is going to satisfy. And what does this CL: denotes is, whatever object that comes in here and it matches, that object is going to be bounded to this variable. This is a local variable. This variable can be used in the then condition. So this is like declaring a variable and bounding it to the object that comes into the rule. So we have bound this claims object, whichever got satisfied, into the CL. So this is the pattern binding part. This is the pattern binding stuff. So this is the pattern, and we have bound the pattern to a CL variable, and that variable can be used in the then part of the rule. So here it can be used to access all the properties, the attributes of the class, just like with setter and getter methods. So CL.setHR approval required true. So I am accessing and setter method of the claims object, and I am changing the value for that particular attribute. I am setting it to true, and I am just getting the same value from using a get method. So this is the usage of the bound variable. It's a variable that is bound to an object so that it can be used in the then part to execute some to get a set values. And as I said, here in this object we have not used any object constraint. This is the object constraint. This is the herein we have not used any layer field constraints. Herein we are using some field constraint, and that is called as restriction. The keyword that is restriction. So it just means that what is the restriction that we are putting. So here we have a field claim amount. On that we are constraining, and we have a literal constraint here. We are saying we have given the literal 10,000, and we are checking whether the claim amount is greater than or equal to 10,000. So there is a lot to pattern matching than this, but this is the basics of the data you need to understand. You have a pattern and you have a binding variable, so that's called the pattern binding, and you have restrictions that can be given. So in this equation there are two restrictions. One restriction is on the object type, the other restriction is on the actual variable. And yeah, most of the time we confuse Java developers, since we are very much used to the Java way of programming. We get confused with how Java method works and a rule works. It's very important to understand the difference. It's very important to understand how a rule works to better code the rules and to better expect the results. If we don't understand how a rule engine works or how a rule works, then we are going to see some unexpected results in the system. So we could avoid that by understanding the basic differences between a Java method and a rule. So where does this come from? Because see, these are two different paradigms of programming. So one follows sequence of statements, one after the other. Each statement is like a command to the system, and that's the Java way of working. The rule is like mostly the rule is given, it's interpreted, and it's more declarative approach. It's nothing to do with the data. There is no data actually embedded into the application. The data is going to flow, and it's not tightly coupled with the data. So that's what is the difference. So basically, if you see, there are two main differences. A Java method. So here in the example that I've given is hello Fedra. So in the Java world, we would write a method to print hello world, and then we would get an instance of object. While this method is getting invoked, we would be expecting a parameter to be passed into this method of the type user. Then we would be checking whether the name in the user variable, user object is Fedra. If it is, then we are going to print it. But in the rule world, we just say we have a condition check there, username equal to Fedra, and then hello Fedra. So the main difference, if you see here, is the Java method is expecting a particular instance that needs to be sent while the method is going to be invoked, and then it has this condition check. But if you see the rule, it's not expecting any particular instance of data, and there is no way of invoking this rule directly. There will be a set of rules in the system. All that we could do is fire all the rules and pass the data to it, any data to it. We cannot pass any specific data to it. All the data that is passed, like we can send 10 user objects, 20 user objects, and it will apply this rule on all the user objects and then give us a result. And any particular rule in the system cannot be invoked directly and pass the instance of data. If you see, there is no input parameter and all here. It's just that we need to put the data into the working memory, and the rule automatically picks the data and tries to apply the rule by checking whether the condition gets satisfied or not. That's what it does. So there is no way for us to invoke a particular rule directly and pass it some data. But in Java world, the only way to do is we need to invoke a method directly on the object type and then pass it an instance of object that it is expecting as its input parameter. So herein we directly invoke it, in the rule we don't directly invoke it. We just have to fire all the rules. So that's what the below statement say, methods must be invoked directly, whereas rules can never be invoked directly. Specific instances of objects will be passed to methods, whereas specific object instances cannot be passed to the rules. And prerequisites, we need JDK 1.7 and Apache Maven 3 Plus to get started. So these are the two basic software that you need to have it installed in your system, in your developer system, to get this started. And then the JBoss software itself, you got to download this BRMS and the Developer Studio, and both are jar files, and you can basically install it. and I've given the steps to install the plugins. Just go to help new software, and these are the plugins which makes this Drools and Drools work. Actually, there is a lot of feature that you can configure a runtime. You can create a Drools project out of the box. It does come with basic rules and all that. So this should be easy. And setting up Eclipse, they have provided, these plugins provide full integration into this Drools. So once you install, we get this Drools option. We will be able to select the Drools runtime. Drools runtime is nothing but a set of jar files. That's it. We can set up the Eclipse and start working in the Eclipse. Basically, I do use JBoss Developer Studio because it has got all full-fledged features and support for this particular Drools. And the most important thing, the difference between the two paradigms of programming, the traditional programming approach versus the declarative programming approach. See, traditional programming approach is the one we do with object-oriented programming languages, Java, for example, or .NET and as such. So what's the problem with this traditional approach? Basically, the systems are getting more complex, and we are trying to solve more complex processes, and we are trying to automate more complex business processes and then bring it live on a digital platform. So when we do that, there are lots of business logic that needs to be encoded as statements. So that is where we encounter a lot of problems. Why? Because these in the traditional approach, there is no standard template or standard definition where they have mentioned how a rule should be coded, how a business logic should be coded. We just write the business logic as part of our algorithm itself, and it gets tightly the what needs to be done, and how is the algorithm part, how it needs to be executed. So what comes from the requirement that we get from the business analyst, and how is the way we are solving the problem. But both these are getting tightly coupled in a traditional approach. So that's where when the systems become complex, it's very difficult to maintain or change or modify the business logic that we have coded into the system, because it's very difficult for us to separate what is the algorithm and what is the actual requirement that comes in. So these are some of the problems, and mapping a requirement to code is difficult. So if you have 10 requirements and you have coded that into the application, it's very, very difficult for someone to map and say that this particular condition is written for this particular requirement. Mostly what happens, some requirements get coupled up and written as one single condition, or sometimes it is all over the place where the condition is executed. So it becomes difficult to map, and whenever there is a change in the requirement, it becomes, as we say in the software world, it's always difficult to manage change and maintain the code. The reason behind, it's not the same developer who developed the system is going to sit on the same software for years and together. The developers are going to change, the business analysts are going to change, the requirements are going to change. So change is the only constant factor. So when that happens, when developers change, it's very difficult for another developer to do the same way. And then the code becomes out of sync and it becomes a mess very soon than we expect it to. So when the business logic is embedded into it, it becomes very difficult for us to refactor and understand what is coded earlier and how to change it in a systematic way. So and then business analyst has got no way to actually understand or verify what exactly is coded in the system, what is the implemented logic. That person has to rely upon the developer. Even for the developer, it's not an easy job, because not always the same developer is going to see the code. If it's a new developer, then it is difficult for him also to go through the code and then understand the business logic that is applied in the application. So these are some of the problems. We'll see how this declarative approach solves these problems. Rules are declarative, right? So we will write it in plain English, and we can map each rule to a requirement. So for a particular requirement, we will be able to write a requirement, we will be able to write a rule and then keep it. So there is always a possibility, like most likely a rule will be mapped to a requirement, or a requirement can be mapped to a rule. That's for sure. And the rule engine uses this streak algorithm, and it has got this efficient algorithm in applying these rules on the data very efficiently. The reason being that algorithm is like it does not, as the rules become more and more in the system, as the rules increase in the system, the algorithm performs doesn't degrade. The algorithm performance is not actually dependent on the number of rules. So regardless of the number of rules, the performance is going to stay the same. So that's the basic advantage, and it's not like most improved, but definitely improved than the traditional approach of executing the rules. And it's easy to maintain because we are able to map a particular requirement to a rule. It is declarative. It is very easy to understand for the developer what rules are coded into the system, what is applied, how it is plugged in. So it's very easier to maintain. And since it is declarative, and since it is out of the application and an external system, it will be easily verified by a business analyst. So we could work very closely with the business analyst and modify, change, like at least see what is happening on the system. So business analyst role becomes much more easier here, and even for developers, the new developer comes in, you will be able to understand it, the readability, the understandability, and all that thing to understand what is written in the application is easily understandable here. As I said, requirements and rules will be more likely mapped to one-on-one. Advantages, as I said, it's the same thing. It's easier to understand, easily maintainable. It provides us improved performance. Rules can be reused. Since it is externalized, any system can apply a set of rules to its execution. So it's reusable. Rules can be easily integrated with business processes. So this rule is works hand in hand with JVPM. JVPM is the process engine, rules is the rule engine. So both of them are part of the same core engine, and it's part of the bigger BPM suite product. The rules will be integrated into the business process engine, and it will work together as part of the process. And rules can be modified and deployed without having to bring down the application. So as a rule modifier, the system will be able to take and work with the modified rule. There is no downtime there. Disadvantages, it's definitely we need to understand this new way of programming because it's not as similar to the object-oriented programming. We need to understand this so that we don't make any mistakes and we don't degrade the performance by a coding standard. The rule engine itself is good, but if we code the rules in such a way that it's going to apply again and again or some looping condition happens, that is going to degrade the performance. We need to do that. It's difficult to troubleshoot the issues because it's not a sequential flow. It's going to be, the execution is going to be all based on which condition in the when part of the rule gets satisfied for which data. So it's difficult to understand how if there are multiple rules and then there are more than one object into it. So we need to understand how a rule engine will work behind the scenes so that we would be able to troubleshoot issues. But there are some tools available which makes our life easy, but still understanding the internal workings of a rule engine is very important. And it consumes more memory, but since memory is cheap all these days, I would consider this as a disadvantage. But still, if your application is in an environment where the memory is a constraint, then it's not advisable to go for this. It's a disadvantage there. When not to use the rule engine? So when the rules are very minimal in an application, so you have very little number of rules, it's a simple application, small application, then you don't have to go for a rule engine. Rule engine would be overkill there. But again, you got to think long term. Everything is going to start as a small application and later on it can become big. So it's all depending on case to case basis. If your application is never going to grow, it's a simple application, then yeah, you don't have to go for this rule engine. And if the business logic is more stable, some applications are there where it's not going to change forever. It's once coded as coded. So in those sort of scenarios where it's very stable, you don't have to go for rules engine. And if you want to have a better control over the code execution, if you have a better algorithm, or you want only that particular sequence or that particular algorithm to be executed for this particular implementation, then you cannot use rules because rule engine has got its own implementation, the own algorithm, and it will execute only in that. You cannot influence it to change it. So rather, if you have to do it in your own way, then go for your normal programming style. And do not have sufficient trainings on rule engine for the developers. So in that case, also go for you got to train your developers. Otherwise, you got to drop out of rule engine. So these are all the scenarios when not to use the rule engine. And Thank you guys. This is the introduction. Thank you.